Welcome to class. Welcome to our digital SAT Maths prep. In this class, we are going to be looking at different digital SAT Maths questions for different modes. Like you know that SAT Maths exam usually hold every month. So today we are looking at some questions from the October diet of 2025. So we have 5 questions here. We call it part 5. In our next video, we're also going to look at like 10 questions. We call that part 2 of the October diet. So these are with having some questions every month. So let's go. Number 1 question here for the October diet says that the function s of t is equals to 64% of t less than t, where t greater than 0. So they're asking you, is it increasing linear, decreasing linear, all of that. So let's explain this question. So they say 64% of t. It actually means 64 over 100 times t, and that will give you 0.640. Now look at this. Now it has said less than t, so that means that our s of t is actually t minus 0.64t. That means 64% of t less than t. That means you get your 64% of t, which is this, less than t. That means t minus 0.64t. And if I factorize this, I have t bracket 1 minus 0.64. Then if I subtract, my answer will be 0.36t. This is my s of t. So they're asking us, is it linear or exponential? Is it increasing linear or decreasing linear? Let me talk about before I talk about linear, you can compare this by comparison. You can compare this to y equals to ms plus b. In this case, our b is 0 and our gradient is 0.36. So since our gradient is more than 0, if our gradient is more than 0, it's not negative, so it's going to be increasing linear. So our answer is increasing linear. So let me really talk about increasing linear. Go. Now, for linear function, we have y equals to ms plus b. This b is called the y-intercept. That's the point where your s equals to 0. The point where the line cuts the y-axis, something like this. So this might be here. So the b can be positive or negative, it depends. So if m is positive or greater than 0, it is increasing linear. It is increasing linear. Then if m is negative or m is less than 0, it is decreasing linear. So for this our question, our m is greater than 0, so that's why it is decreasing linear. So if m is negative, it is decreasing linear. So if you have an equation that is of this form, you say it's linear. Then let's talk about exponential. It's going to be exponential. This is exponential. We are still going to make a video on exponential so that you can look at it later. For exponential function, y equals to a dot b raised power x. So if b is greater than 0, it is increasing exponential. Increasing exponential. Or you call it exponential growth. That reminds me, you can also call increasing uh, uh, linear growth. So you call it exponential growth. Then if b is less than 0, then it is decreasing linear, decreasing exponential. Or you call it exponential decay. Or you call it exponential decay. Like e.g., and your a is usually the a is the initial value of y when x is 0. This a here is called the initial value of y. Initial value of y when x is 0. More like the value of y before it starts increasing or start decreasing. Most of the time, increasing exponential is something like it's increasing by times multiple. Decreasing exponential is something like it's dividing. So this, you can call this a linear growth, linear decay. You can call this linear growth. This is more like plus. This is more like plus, and this is more like minus. This is what I mean. I'm taking my time to explain all this. Let's say if I have x and I have y, x is like 0, 1, 2. So let's say when x is 0, let's say y is like 10. Let's say y is like 11, 12. Yeah, I have plus, 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 plus. This is linear growth. So let's say I have another thing like this, x, y. Let's say I have something like 1, 2, 3. Let's say this one is like 15. This one is like 10. This one is like 5. Yeah, I'm having minus, 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 minus for value of y. This one is linear decay. If I plot this graph, m will be negative. But let's say I have something like this, x, y. Let's say I have 0, 1, 2. So this is like 4. This is like 8. This is like 16. This times. This is called exponential growth. So in this case, my a is 4. In this case, my a is 10. Then if I have something like this, 0, 1, 2. Let's say I have something like 16. So I have something like 8. Right, for I can start as an exhibition here divided by 2. This one is exponential decay. So I want to explain all this later. But this is I've just given a general overview of increasing linear, increasing. So this is exponential decay. Let's go to number 2 question. Number 2 question says that Steve is going to go running and biking. So let's have like this, running and biking, for a total of 25 miles over a 3-hour time. He runs at the speed of this and that. Which are the following? So let's start with time. We are not given the time for running. So let the time for running be x. Let the time for biking be y. I'm taking R for running, taking B for biking. So the total time The total time for running and biking is 3 hours. So that's x plus y equals to 3. Equation 1. This is actually equation and systems of equation. Just a word problem. Then look at the next statement. They say it runs at the speed of 7.2 miles per hour and bikes at that. So your mind should go to speed. We call that speed is what? Average speed is distance over time. So we call that speed equals to distance over time. And distance from here is speed times time. So let's go. So let's talk about distance. So the distance for running, what is the speed for running? 7.2 times x. 7.2 is the speed for running. Yeah, 7.2, and the time for running is actually what? X. Okay. What is the distance for biking? No, distance is what? Speed times time. Distance is speed times time. So what is the speed for biking? Speed for biking is this 11.4. Why this is the speed for running? So the speed for biking is 11.4. Using this one as distance equals to speed times time. 11.4 times time. So what's the time for biking? It's actually y. So let's take our total distance. So that is how it will be distance for running, which is 7.2x plus that speed times time, speed of running and the time of running, and plus the speed of biking and the time for biking, 11.4y. The total distance is this 25 miles. 25. Equation 2. So if I solve equation 1 and 2, what are we looking for, by the way? They say which of the following is closest to the amount of time, I mean the time is spent biking. The time for biking, don't forget, is 1. So I'm looking for 1. So if I solve, so y is unknown. So if I solve equation 1 and 2 using your calculator, and calculator is aligned SAT, you can also use the decimal graph calculator. So if you solve the equation, the 1 and 2, you will get your x as solving 1 and 2. Solving 1 and 2. I'll get my x as 2.19, and I'll get my y as, you can solve that on your own. I'll get my y as 0.095. So since I'm looking for the time for biking, and our time for biking is y, so here's my answer. So that's 0.8 hours. Let's go to question 3. Question 3 says that right angle triangle ABC has angle B as right angle. So let's say I get a right angle triangle like this. This angle 90. So the right angle is at angle B. So I can label any other sides anyhow. So let me call this A. Let me call this C. Okay. Side AC is length 24. So these are side AC 24. And side AB is 6. So these are side AB 6. So you said the area of the triangle is equals to K cos C. Okay. Let's say this is angle C. I said the area of the triangle. Area of the triangle is actually what? Half base times height. And that's the same thing as what? It is equal to what? K cos C. So more like this equals to this. So let me see if I can get my cos C. Cos C. Let's call this base the base. Let's call BC the base. So cos C is actually adjacent to hypotenuse. So adjacent over hypotenuse. So our adjacent here is what? B. Our hypotenuse is 24. So cos C is actually B over 24. So let's use the formula. That is half A of triangle, half times base times I is equals to K cos C. So we have to find the value of K. So let's go. So half times, what's our base? Our base is B. Times what's our height here? Our height is like 6. Is equals to K cos C is now what? B over 24. So what do you observe here? I can easily strike out. I can easily strike out. I can easily strike out. I can easily say B cancel B. 2 here 1, 2 here 3. So 3 equals to K over 24. If I cross multiply, it's 3 over 1. K will be what? 72. So that's the answer. So K is 72. Let's go to question 4. Question 4, it says the equation of a circle is listed below. Find the expression for radius in terms of A. This is a constant. So this is a question on circle. Let me talk about some background knowledge on circle. So let's say this is a circle like this. So let's say this is center O, center A and B. This is radius. It's a general formula called equation of circle. One of the formula for equation of circle is x minus a all squared plus y minus b all squared equals to r squared. This one is called the equation of a circle. Equation of a circle. But I will not use this formula to solve this question. There's another formula called, if we can say I'm giving you background knowledge. There's another formula called the general equation of a circle. That one is x squared plus y squared plus 2gx plus 12y plus c equals to 0. This one is called the general equation of circle. This one is called the general equation of the circle. So I'm going to use this formula to solve this question. But if you're using this formula, you have to take note that of something. Number one, if you're using this formula, you have to take note that the center A is minus G, the center B is minus F, and the radius is square root of G squared plus F squared minus C. So let me call this one 3, let me call this one 2, let me call this one 1. So I'm going to use some formula 2 and 3 to solve this question since we have to find the radius. So let's go. Our equation is actually what? X squared minus 2ax plus y squared minus 6y minus 14a equals to 40. So I want this equation to be like my equation 2. So I will arrange. So if I arrange, I will have x squared plus y squared minus 2ax is a minus 2ax. Let me write it first so I can see. Minus 2ax minus 6y minus 14a. If I bring this 40 here, it came to, no, this is equals to 40. So it came to minus 40 equals to 0. So if I compare by comparison, by comparison, if I use x squared plus y squared plus 2gx plus 2fy plus c equals to 0, I can easily tell that, I can easily say this equals to this, I can easily say this is same as this, that is minus 2ax is equals to 2gx. Then I can easily say that this equals to this, that's 2fy is equals to minus 6y. Then I can easily say that c is equals to this. Okay, we write that. Let's do this first. So that equals to this. So from here I can say this cancel this. So from here I can say g equals to minus 3. This cancel this. 2f equals to minus 6. From here I can say f equals to minus 3. Then if I compare again, I can also say c equals to what? C equals to minus 14a minus 40. And that's, I can change that to minus bracket 14a plus 40. So that has to find, you have to find the radius. It's a final expression for the radius. So the formula for radius, so that's what we call that r equals to square root g squared plus f squared minus c. So r equals to square root, our g in this case is now minus a squared plus our f is minus 3 squared minus c. See our c here, minus brackets, sorry, our c is now mistake here. So our c is now minus opening bracket 14a plus 40. So our r is now square root of minus a square will give us a square. This is 9. So give us plus 14a plus 40. So if I rearrange this, so we have r equals to square root of a square plus 14a plus 49. Okay, this is actually a perfect square. This is actually a perfect square. This is a perfect square. I want to do something. Look at something. This is a perfect square. What do I mean by perfect square? Let me show you. We call that what? We call that a plus b all square is actually a square plus 2ab expansion plus b square. This was called perfect square. More like the way you say your 2 square is 4. So a plus b all square is a perfect square. So that will give me this. So the same way, a plus 7 all square to give me a square plus what? Um, plus 2 times a times 7. That means b is not 7 plus 7 square and that will give me a squared plus 14a plus 49 is a plus 7 squared. So what am I trying to say? So go back to this question here. I will change all of this. I will change all of this to a plus 7 squared. So r is now square root of a plus 7 all squared, and this cancel this. So my answer is so this square cancel this. So our answer is a plus 7. So let's go to the question. So our answer is a plus 7. That's option B. So that's that. I'm going to make a video on circles, explain what the uh, formulas in detail. Well, I've actually explained the basic part and solve more questions on circle and set. So watch out for more videos on circle. That is number 5. Number 5 says that for n and k as positive constant greater than 1, n equals to, so they told you that n 5 over 3 is equals to k is power 3 over 2. So you say for what value of this is k equals to, for what value of this k equals to, sorry. So for what value of this is k equal to this. So that means k is now n equals power 2a plus 1. So that means anywhere I see k, I'll put n raised to power 2a plus 1. So this is n raised to power 5 over 3 is equal to, what's our k now? N raised to power 2a plus 1, close the bracket, 3 over 2. I've substituted the value of k here with this, because it told us that k is also equal to this. So I'm looking for the value of a now. So that will give us n equals to power 5 over 3 is equals to, so this 3 over 2 multiply everything here. So 3 over 2 times 2a, that will give us 3a. 3 over 2 times 1, that will give us 3 over 2. So at this point I can easily equate. I can easily say this cancel this. So I'll be left with 5 over 3 is equals to 3a plus 3 over 2. So what will I do from here? What's the LCM? It's like over 1. So the LCM is let's say the LCM is 6. The LCM of the denominator, the LCM of 3, 1 and 2 is 6. So multiply 2 by 6. So that's more like 6 times 5 over 3 equals to 6 times 3a plus 3 over 2 times 6. And this will have been this will have been 10, 18a, this will have been 3. So so if I collect like terms, so I have 10 minus 9 equals to 18a. So what is 10 minus 9? I have 9 equals to 18a. So I have a equals to 9 over 18, which is equals to 1 over, that's 1 over 2. So that should be it. Let's check our workings if I don't make any mistake. Okay, 8 from okay, it's 5/3. Okay, so I think that's it. So that's it. That's it. So we find the LCM at this point. At this point here, and we multiply everything by the LCM. So times 6, times 6, times 6. So that's it. That's the end of our class. So watch out for our second video, part 2, where we also dissect another some questions from October series. Thank you all for joining us today.